Hello, so we are back, and this time we have a nice laptop, and trust me, this is a nice laptop and expensive. So we have the ASUS ProArt. Have you seen something like that? ProArt Studiobook, and we have i7 and RTX Studio graphics. Not sure what is this, but this looks very expensive. I believe this is a screen. Huh? What do you think about this laptop? Can we fix something like that? Huh? So let's see what the customer is saying. So the customer is saying ASUS first problem was a loose DC port, only charging at certain angles. I had it repaired by a local repair guy using a port I purchased myself. Was fixed, but suddenly had a new problem. Windows was saying plugged in, but there was not even a time until fully charged. It is not charging the battery. Okay, this is strange. So basically, they replaced the charging port and the laptop actually stopped charging. But I had another email from the same customer, and the customer is saying the laptop it will not start sometimes. The solution is to leave it plugged in. It start happening out of the box. Seen by few people, but only work by one. You know what? Who melted a little bit of the extra M2 socket. You know what? Always when there are like many repair people, things can go bad because always the next guy it will not know what the first guy did, and that's why it's more complicated. So we do have the charging port sent by the customer. The problem is I don't have the charger, but hopefully Asus doesn't use the charger ID pin. I will say let's open this laptop and let's have a look inside. And the laptop is open. Lol, a proper nice machine. Huh? What do you think about that? Proper nice. Never seen or repaired this laptop before. So what is here? Hmm? It is a nice laptop. Now let's check few things. Yeah, let's check the main power rail to see if it's present. Main power rail, we have a current sensor here and we have 2.6 volts. Lol. Main power rail here, 2.6 volts. Main power rail here, no, here is the battery voltage, 15 volts. 15 volts. Here, not sure what is here. Okay, so we have MOSFETs, and here we have 15 volts. Okay, here is the GPU, and we have the current sensor on the GPU. 15 volts. So the main power rail, it is present, and the battery voltage, it is present. Means this laptop indeed has a charging issue. Oh, I can see now. Yeah. I can see where it was worked before. The charging port and the M2 socket. Yeah, got it. Okay, I will say first, let's replace. Actually, no, first, let's see if it's charging, right? So we have 20 volts. Let's see what do we have there. What pins do we have? Yeah, we don't have charger ID. That's fantastic. So we have plus and minus. But this plus is no solder. No, this is not plus. This is ground. Okay, this is ground. So plus here, and the laptop is taking no power. Huh? It is taking 30 milliamps. Only 30 milliamps. That's all what it's taking. Okay, let me unplug the battery. Unplugging the battery, and it's still taking 30 milliamps. So why this? Why this happen? Why is taking only 30 milliamps? Anyone knows? Okay. We are not moving forward yet. I will say, yeah. Let me stick the ground somewhere. Here. Yeah, it's no space for both. Here. And let's see if the main power rail is present when I'm coming with the power at the charging port. So here is the GPU, okay. And plus here. And no. 17 volts. What? One second, I have 19.5 on the power supply. But all what I'm getting like 17 volts. Of course this will not charge. Something is wrong here. But the voltage is going up slowly. Do you think? But no, forget about that. I was thinking, maybe it's a power supply which is creating the main power rail, but I don't think. Or maybe. Hello, maybe. Ooh, maybe. Okay, let's check one more time. Still, let's say you have a power supply which is creating the main power rail, and obviously the battery is connected to that main power rail. How the voltage is jumping to 17 volts so quickly? Huh? That's mean a very high resistance battery. But we can figure it out very quickly. Because if the charging port is good, I'm not going to replace the charging port. I'm sorry. Plus here. Yeah, it's taking 30 milliamps. So I'm assuming here is the input from the charging port. It is 19, check on the screen. And on the output, I'm assuming this is the output, and it's 17. And on the battery, it's 15. No, it's not charging. No, the battery is good. It's not charging. So the battery has to be connected to the main power rail, but looks like it's not. 15 on the current sensor. So I don't understand actually the charging. 1 second. Let me try to figure it out. No. The comeback MOSFET. Where is the comeback MOSFET? This one? 15. And on the other side we have 15. Okay, if this is the comeback MOSFET, then what is this? Oh, this is a power. This have nothing to do with the battery, right? Probably. Then 1 second. Then here I should have 7. No, I have 15. And here 15. And here 15. Lol. Because I'm not touching here. That's crazy. No, actually my ground sucks. No, 30, yeah. So this MOSFET we have 17, and here we have 17, and on the battery we have 15. On the current sensor we have 17. One second, because I don't understand what's happening here. We have to figure out the schematic. If we're not able to figure out the schematic, then we cannot fix it. No. So check here. No. So yeah, the main power rail has a design specific power supply, which is this one with a bunch of MOSFETs. Yeah, good. But the battery has his own charging circuit. So this is the charging. Then we have this MOSFET here, And here is connected, the battery is connected here, right? Not here, no, one more MOSFET to the battery. Not sure what is the point of that MOSFET. Huh. Okay, let's check few more things. Yeah, let's check few more things. We are coming again with the voltage on the charging port, and the ground sucks again. And it's taking 30 milliamps. Okay, so on this MOSFET we have 17, and on the other side we have 15. Yeah, so we are losing the current exactly here. That's the reason why this battery is not charging. But on the opposite way, without the, so I don't have power on the laptop on the charging port. So I have 15, and here we have 15, and yeah, now it's fine. So this laptop sucks from some reason, and we don't know why. But we can try. Let's test that laptop, that MOSFET, and see what it's doing. It's like freaking 0 ohms MOSFET. You can see it's 0 ohms, and you will ask now, Sorin, this is strange because when if I plug the battery, I have 15 here and I have 15 here. But when it's about charging, I have 17 here and I have 15 here. Yeah. Remember, I always told you a shorted MOSFET, the internal resistance is quite high. And because of that, obviously the laptop is off. I plug in the battery, we have 15 and 15. But when the laptop tries to charge the battery, yeah, so here we have 17 and here we have 15 because we are losing the power on this MOSFET. I think we can see that on the thermal camera. Yeah, I think we can see it. Let's try it. Now it's taking like 800 milliamps. The laptop is coming on. Yeah, we reset the BIOS. Yeah. Okay, anyway, we should see that MOSFET, right? Where is it? No, we can't see it. No, probably has some MOSFET short circuit detection. Okay, that's fine. That's okay. But look now, yeah? Look now. So now the laptop is on, right? Because you reset the BIOS. Let's check the voltage. Yeah, the laptop it is on. So the voltage before the MOSFET is 14.6 and after the MOSFET is 14.6. Okay, that sucks. Let's disconnect the battery. Let's check one more time that MOSFET. So one more time, this MOSFET has exactly 0 ohms. You can see? Yeah. Good. Now let me take out the battery. We can replace the charging port also. It's not really a point because the charging port is fine. But yeah, let's see what we can do. Now, anyone can tell me why the technician melt the M2 port here? Why? Anyone knows? You know why? And I said it so many times. Charge the right amount of money. I mean, if you are in rush, yeah, then it's no point doing it. You know what I mean? So this is way over like the dodgy things I'm doing. You know, like actually not using some Kapton tape to protect this corner of the M2 drive. So probably the technician was in rush, and you are in rush when you are not charging the right amount of money, especially for like expensive laptops like this. I mean, don't get me wrong, but this laptop probably it's over 3K. You know what I mean? For 3K laptop, you cannot expect the charging port to be replaced for £80. To be honest, I will not replace the charging port under £200 for a laptop like this, and it's because of the risk. You just you drop the probe here, and you have to take out from your pocket £3,000 and buy another laptop for the customer. So you are charging for the risk, yeah, not for actually replacing the part. I'm just trying to explain it because Those accidents are not meant to happen. I'm just saying you must be covered. Yeah. So you charged £200 and you didn't melt anything. Yeah, you took enough time and everything went like perfect. Yeah, that's fine. That's okay. You have some extra money you can put on one side for the moment when accident happens. Yeah. Now, to be honest with you, I'm not confident replacing this nozzle because I don't know what is on the other side of the motherboard. If you have a ribbon cable going there, I can melt it. And again, this is an expensive one. Let me take the motherboard out just to be safe. You know what? I really understand. So when I start actually charging money, I was just a little boy. I have a bag and I was going to people's houses to fix, stereo, tape players, TVs. On that time, I remember was like black and white TVs. And this was a big issue for me, for myself. I mean, I was like ashamed to charge the right amount of money, and I always charge less than I was supposed to charge. Just because of that, you have that fear, you have that, you don't know how the customer to react. Actually, the problem is you are not appreciate your skill. You are assuming like everyone else has the same skill, but that's not right. Everyone is unique. So try and be more confident on your skill. But yeah, I do understand that, when you just start repairing, you have a little bit some knowledge about electronics and you start repairing, and first to the friends and friends of the friends, and the moment you have to ask for the money, that was the hardest moment. I mean, I was fine repairing, but asking for money, yeah. But yeah, I was like 16, 17 on that time. Okay, so the motherboard, it's out. Proper nice, huh? Yes, I will say let's replace this charging port, yeah? Perfect. So I'm gonna use hot air. This is a small nozzle. I need a bigger one. 1 second. Okay, this nozzle is better. I'm desoldering the port with max temperature, 480 degrees Celsius, because this is the faulty port anyway. Perfect. So we remove the port. Now the board is still hot, right? Quickly, we are using solder wire, 190 degree solder wire. Good. Perfect. Not sure what is here inside. What is this? Let's use more solder then. Perfect. Perfect. So here on this side everything is perfect. Now on the other side of the board, the same story. Let's apply solder just to lower the original solder melting temperature if we can. Yeah, we can. Perfect. You can find on our eBay or United States eBay on the description this solder wire, which is, I mean, don't get me wrong, I can do it without using low melt solder. Actually, it's no low melt. 190 degrees is no low melt. But just because I have it, yeah, we can make the work a lot safer. Good, now let's clean it. Let's make it nice. Better, right? Yeah, looks better. Now you have the new port, yeah? You have the new charging port. Yeah, everything is perfect, which is this one. Good. And you have to solder the port, right? How you will solder the port? Hmm? And you will say, sorry, you clean it. You have 190 degrees solder wire there. So you can come 190 degrees and we can solder the port, and that's right. We can isolate with Kapton tape, yeah? We have Kapton tape. We can isolate, yeah, nicely. We can isolate the port, the M2 slot. But what is the point when you have, yeah? So check here. You have everything free on the other side. I mean, you have nothing. I mean, on the same way, you can come with the heat from the back. It's not. It's making no difference if you come from the other side or from this side. Huh? So no point, risking to solder from that side when actually we can solder from this side. And we're gonna do it together under microscope. So you know what? We lost that pad, which is not used anyway. I found inside of the holes like small metal pieces from probably from the first charging port. Now let's solder the charging port. And the port is on place. Now quickly let's solder the pins from this side. Perfect. Perfect. We need some hot air there. Perfect. Perfect. Rosin. Perfect. I'll come with the hot air with 200 degrees. With 200 degrees we cannot melt anything. Perfect. It is perfect or not? Hmm? Now let's clean it. Looking like brand new, right? Yeah. Looking good, yeah? So we can say the charging port, it is soldered properly, right? Yeah, we can say that. Now let's check the MOSFET. I will check one more time this MOSFET just to be sure it's soldered, is shorted. Yeah, 0 ohms, it is shorted. Let's remove the MOSFET. I'll use 480 degrees Celsius, 50% air. Good. So what MOSFET is this? Okay, so this is an N-channel MOSFET. Let me grab another one. Where we can find an N-channel MOSFET here. We found exactly the same not same MOSFET, sorry, same configuration. So from the plus of the battery, it's going to this MOSFET on the source. Same like here, right? Yeah, same like here. So yeah, let's remove this MOSFET. This is from a spare board. Perfect. And let's solder the MOSFET here. Perfect, so the MOSFET is soldered properly on place. Now I will say, let's put the board back and let's check if it's charging. Perfect, everything is connected. I didn't fit this thingy. Let's connect the battery and let's do a test. So the battery is connected. Power supply, 19 volts plus. Why is not charging? 1 second. That doesn't need that one, right? Need these cables? Okay, let's connect the ribbons. We broke the customer laptop, it's not coming on anymore. It's not my fault, someone else work here. Good, so we connect the ribbons. Let's see again. Minus, plus, and no, it's not taking any power. Lol. Okay, let's let's power on the laptop. Let's see. Oh, actually, the power button is on this ribbon cable here. So, minus plus, pressing the power button, and nothing happened. I have ground? I do have ground, yeah. Okay, that sucks. Let's see what's happening here. Let's see what's going on. So the main power rail, let's see if it's present. The main power rail is 2 volts. Why the main power rail is 2 volts? One second. Plus and minus, right? And plus is coming exactly here, right? No, it's not coming here. Where the plus is going? Okay, let's study the problem. Let's see what's there. but doesn't look good. Okay, the schematic is one sec. We have picture on the screen. Lol. 12 gen CPU. We have picture. Okay, let's come now with the power supply, yeah? So power supply, we have ground, and we have plus, and it's not charging. Why is not charging? $19.5. It's not charging. The laptop is working, but it's not charging. Okay, let's shut down the laptop. Good. I mean, before it was taking like 30 milliamps, but not anymore. Let me unplug the battery. Good. And let's check the schematic here. We have the charging port, we have an inductor here, and we have two resistors, and from here it's going somewhere. But not sure where it's going because I didn't took out the heatsink. So here everything is fine, it is soldered properly. I have to take out the heatsink to see where the voltage is going. I try to avoid taking out the heatsink, but I have no choice. Okay, so the heatsink, it's out, lol. Liquid metal. And here, yeah, we have MOSFETs. We have input circuit. Check here, we have two MOSFETs here. Let's check the MOSFETs. So this one is good. And this one is good. Let me come with the power supply. So coming with the power supply at the input, yeah, here. Good. Output of the first MOSFET. Output of the first MOSFET is, yeah, it is. Let me lower the voltage. Yeah. So output of the first MOSFET is 19. Output of the second MOSFET is 0. And someone play here or not? No. Why the output of the second MOSFET is 0? Because I'm assuming the gates, I have 18. I have 18. 1 second, I should have 25 here, right? So this input circuit is not working. Let me check if the gates are together. And the gates are together. Yeah, so those are two channel N MOSFETs. I should have 25 on the gate. So between source and gate, we have like 0.9 volts. Both MOSFETs are channel P MOSFET. So we have to find who is managing those input MOSFETs. Good morning. So the time is like 20 past 4 in the morning. Sometimes, the things are not making sense. And on that moment, they're just bugging me. Like this one, we replaced the MOSFET, the shorted MOSFET. We checked that MOSFET probably 4 times, and it was shorted. So we replaced the shorted MOSFET, and the main power will disappear. So what I did, I took out the charging port. The charging port has a charger ID pin there, but I don't believe it's used. Anyway, I took it out. I soldered back the old MOSFET, and the main power rail came back to life. I mean, how you can solder a shorted MOSFET and you have your main power rail back? More than that, I ordered the ISL chip 9241, which is responsible. This is the power management chip. Is responsible with into creating the main power rail and charging the battery. Anyway, I do have this chip data sheet, this one. And the schematic I have here is different compared with what we see in here. So on this schematic is not a dedicated charging circuit for the battery. But here I do have a dedicated power supply, switching power supply uh, for the battery charging. So with the old MOSFET, with the original MOSFET here, we have 19 volts here. And also I have 19 volts on this big power supply, which is creating the main power rail here. Now, this is something interesting, yeah? E180AJ. You remember this was the original MOSFET, which was shorted. Now, let's check back that MOSFET. So check here. Here to here, no short. Here to here, no short. So how you can explain that? We checked this MOSFET probably like 4 times, and it was shorted. So I soldered back the original MOSFET, and now when I came with the power supply, so coming with the power supply on the charging port, it's taking like 900 milliamps. Yeah, so the main power rail, it is present. I do have 19 volts. So one more time, our MOSFET, our shorted MOSFET is not shorted. With a different MOSFET, channel and good is not working, the main power rail is not present. And I did check the datasheet of this MOSFET, and it's like a regular MOSFET. And we solder back the MOSFET, and it's not shorted anymore. Then I start getting deep into this motherboard. And I checked this big power supply, which is creating the main power rail. Yeah, so the power is coming here, the 19 volts. Then we have 4 MOSFETs, which they are switching this coil. Now the MOSFETs drain to source are good. But let's pay attention on this MOSFET. So this MOSFET is basically, after this MOSFET, we have the main power rail here. Main power rail created by this coil. But this gate to source, we have 1.4 ohms. Check there. But it's strange because drain with source, we have no short. And I don't remember to see a MOSFET actually with the gate shorted, but actually drain to source is fine. So I would say, let's take out that MOSFET and let's try to figure it out if the short is from the ISL chip or it's actually the MOSFET. Okay, so the MOSFET, it's out. Let's see what is shorted there. So, gate with source, and it's not short anymore, yeah. It's a shorted MOSFET, but only gate. No, it's not shorted anymore. How? I mean, how this is possible? So check it is not shorted anymore. No, it's not short. I don't understand. This is the second MOSFET that I'm checking and it's shorted, and after I remove it, it's not shorted anymore. Okay, let's solder the MOSFET back. Okay, so the MOSFET is soldered back in place. Let me cool down the board. Now checking again, gate to source is not shorted. Check here, it's not shorted. That's insane. This is over my understanding power. So I'm curious, what will happen now if we are testing this board? Still hot? How you can have on a motherboard two MOSFETs, shorted, removing, resoldering the MOSFETs, they are good. Okay, let's show you one more time. Connecting the battery, coming with the power supply, plus, and it's same, 900 milliamps. Nothing changed. Let's remove the battery and let's check that MOSFET again. Gate is source. It's shorted. Check that. 1.4 ohms. How? Just tell me how. How this can make sense? The only way how this it will make sense. Yeah, it's short. 1.4 ohms. If the gate is charged. Okay, let's discharge the gate. But has a resistor. You know what I mean? So discharging the gate. And it's still short. So it's not a chip. I was thinking the gate is like floating. But cannot be floating because we have a resistor here. So this must be like a weird faulty MOSFET, right? Okay, let's replace this MOSFET. Okay, so the MOSFET is removed. Let me try to find another MOSFET. Yeah, we have some solid MOSFETs here. Yeah, this one must be like 150 amps MOSFET. So let's solder this one. Just a little bit of rosin flux. And the MOSFET is soldered. Good, let's cool down the board. Let's test it now. Plug in the battery, power supply, ground, plus. Exactly the same. Exact 900 milliamps. I can't believe. Exactly the same. Let's check. Let's check the gate with source. So gate with source is short. 1.5 ohms. Check on the screen. You know, a fall like this can drive you crazy. Okay, on this moment, I believe it's actually the chip is faulty. The ISL 9241. Because otherwise I have no explanation. This is making no sense and has no logic. Let's check the gate and see where the gate is going. I mean, this cannot be shorted, it's just a resistor. One second, because I cannot check where the track is going. So these appear to be still shorted, right? So in order to make it not shorted, I have to heat up the MOSFET or the resistor. Let's see the resistor. No, it's still shorted. Short drainage source. Still shorted. Yeah, I shorted every way possible this one. Still shorted. Okay, then I don't understand the fault. But clearly this is not a regular fault. Okay, let me do something else. I have an idea. So I'll keep beeping here and I'll heat up the chip. So heating the ISL chip, nothing happened. Heating another chip and it's working. Lol. Okay, check that, check that. Check that, now it's fine. So what chip did I hit? This one. So the schematic is really different compared with the datasheet of .isl. Now it's not short anymore. No, it's not short. You can see? So where the gate is going? The gate is going exactly here. So how we can explain a fall like this? And now it's shorted. So check here. Now it's shorted because the chip cooled down. Let's reflow this chip. Let's reflow it. So yeah, I'm assuming this is the driver of this power supply. Obviously, we reflow that chip, so we have no short now. From here to here, yeah, no short. You can see nothing. So now it's fine. Let's wait for the chip to cool down and see if it's shorted again. Okay, the chip cooled down and looks like it's not short here. Let's test one more time. Coming with the power supply. And it's doing exactly the same. Exactly the same. 900 milliamps. Let's see. So testing this MOSFET again. Short. Yeah, 1.5 ohms. Okay, so we have no capacitor here on this track, so I'm assuming the chip is just dead. It's dead when it's cold. It's good when it's hot. But we can check that, right? Yeah, we can. We can connect the battery. I can come with the power supply. Yeah, and I can heat up the chip. 900 milliamps. And nothing is changing. 90 milliamps now. Okay, something it does changing. Something it is changing. So now it's only 90 milliamps. $900 milliamps. Okay, let's try that one more time. So we have 1.4 ohms. And the short is gone. Check that. It's not short anymore. And obviously, when it's cooling down, the short it will come back. Let's cool down the board and let's see the moment. So in order to get a short back, we have to plug the battery. Yeah, it's short. 0 ohms. Yeah. That's how that chip is dying. By plugging the battery. So what chip is this? 2N. You know what? Let me check the capacitors around this chip. Let's see the capacitors. So this one is good. This one is good. This one is good. This one is good. So all capacitors are good. But this track is getting shorted. No, it's not shorted. Huh. It was shorted like 1 second ago. So if the chip is shorted, now let's come with the power supply. Low current. And I will come with voltage on the gate. And check that, it's taking 120 milliamps. Lol. I mean, this is a solid short, 120 milliamps. So let's see what is getting hot. Let me raise the current. 900 milliamps. Wow, that chip is mad hot. I just touched it with the finger. I burned my finger. So the chip is mad hot. Yeah, so clearly the short is inside of the chip. Now it's not short anymore, right? It's not short anymore, or the chip died. No, it's not short. Let's plug the battery again. Unplugging the battery. It's still short, lol. Coming with a power supply. Yeah, it is short. So basically the fault is a dodgy MOSFET inside of this chip. Let me find what chip it is. Basically, this is like a classic chip, which is providing like 3 volts, 5 volts, 3.3 LDO, and 5 volts LDO. So I'm not sure I understand what the chip is doing on our configuration. Okay, let's check the LDOs. So pin number 3 and pin number 13, LDO 3.3 and 5 volts. Good, so I'll plug the battery. The battery is plugged in. And we have nothing here. Here we have 3.3, lol. 3.3, but we don't have the 5 volts. It's taking 900 milliamps exactly like before. But the board it's on. So the 5 volts LDO is present. It is 5.2. Lol, a little bit too high, 5.2. So this has 3 volts, 5 volts, and actually is triggering those MOSFETs here. Here you have 14.6 and here you have 3.3. Okay, here is the coil is switching. And on the gate we have like 3.5 volts. You know, this is so weird. So they're using a chip which I never seen it being used on this configuration. I mean, this chip is meant to do something else. But yeah, I believe I do have this chip. Or do you think actually this is a normal behavior? Maybe it's supposed to short the source we gate. But it's not making sense. Okay, let me find another chip. Okay, so I got another chip. This is tested. Okay, let's solder the chip back. So this is 100% working. Okay, so the chip is soldered. Let me cool down the motherboard. Let's check that MOSFET. What is it? Yeah. Good. Now plug in the battery. Unplugging the battery. Now let's check the gateway source. It's still short. Lol, 1.3 ohms. Ah, so that's how it's supposed to be. We spend so much time. So basically, if you have this chip, that's how it's supposed to be. So the normal state of this chip is source with gate shorted. Probably in order to switch off the MOSFET. That sucks. Okay, in this case, we are going back to the same fault idea from the beginning. I'm waiting for the ISL chip to replace. Let me check. And with the power supply, ground plus, and it's doing the same, 900 milliamps. Okay. Yeah, to see you soon. So we are a few days later and I got the chip. Hopefully I got the chip, I can't see it, but oh yeah, it is here, lol. Okay, let's replace the chip. So we will be coming with the hot air from this side. That's the safest way to replace this chip. Yeah, let me use some Kapton tape. And here. Perfect, let's replace the chip. Okay, so the chip is removed. And we have a brand new chip here. I will dip the chip inside of the rosin. Perfect. Perfect, so the chip is soldered properly. Now let's cool down the chip. Now let's try to make a test. Just plug in the battery. Battery is plugged, coming with a power supply. 19 volts. And 870 milliamps. I think that's what the board was doing before, right? Don't tell me I replaced the chip for nothing. So we replaced the chip for nothing, right? Okay, in this point, I believe the problem is the charging ID pin. But when I removed the charging port, there was no pad there, and I assumed that's from the factory because I don't remember ASUS to use the middle pin charger ID. So plus of the battery, we have 14.7, good. And on this side of the MOSFET, we have 14.8. And the main power rail, 14.7. The main power rail is 19.8. On the charging circuit, we're getting 19.8. But still not charging. 870 milliamps is going to the board. Yeah, so the CPU and GPU is hot. This sucks. Let me see if I can find a schematic for this board. No, I can't find any schematic. Let me check the charging port. So on the charging port, what do we have on the original charging port? We have minus and plus. Yeah, over 20 volts. And on the middle pin, we have nothing. So not sure if the middle pin is connected. Let me discharge the charger. Lol, nice spark. And let's check on the diode mode the middle pin. So on the diode mode, no, it's not connected. It's not connected. And from the plus, no. No, I can't see anything with the middle pin. So what we are doing, I mean, we lost a lot of time for nothing. We replaced the chip, is doing exactly the same thing. So basically the laptop is not charging. It is working on the charger, but it's not charging. Still, let's focus on this middle pin. I mean, I can't see any track there. Wait 1 second. So we have this. But what is this pin? 1 second. What is this pin? This one. I haven't seen that one. This one. What is this pin? What is this one? So probably when you plug the charger, that pin is switching something, right? How did I miss this pin? So this one we ground. Is no ground. Let me plug the charger. So plug in the charger, but the charger it is unplugged. Plug in the charger. And now it's ground. You can see that pin is ground. But here was nothing, was no track here. Okay. Let me switch to diode mode and let's search for a track here. Do we have any track? No track. On the other side of the board, No tracks. Okay, so on this point we are missing something. Either we are missing a track here or here. So what do you think? With the multimeter I can't see anything. And nothing here. You know what? Let me bring my, say hello to my little friend and let's start drilling the board. Okay, this one is fine. And we need a clear picture even here. Perfect. Now we have a better picture about what's going on here. Good, let me clean. Now let's see if we can spot a track there. Okay, on the middle pin we have nothing. Check here, yeah? Is no track at all. Nothing. But on the other side, check the other side. I mean, what do we have here? I mean, here we have a layer, not sure if it's a track or whatever it is, and here another one, you can see them. Yeah, those two. Can be ground? Can be. So let's check. And also, one second, we have one more here. So we have this one, we have this one, and we have one on the other side. Let's check with the multimeter, hopefully it's no ground. So with the multimeter, this one probably is ground, it is ground. Then we have here somewhere. I can't see it. And I can't see that one either. Yeah, I can see it now. Yeah. So it's this one. This one from here. And I have no reading, so it's no ground, which is good. Yeah, now you can spot them better. So we have one here. And this one is no ground. This one from here is no ground. So how we can know which one it is? And that's a very simple test, yeah, but we need power. That's what we need. If we have power, we should have voltage there. So what I'm gonna do, I'm gonna plug the battery. Okay, so the battery is plugged. Here I have nothing. Check there, check on the screen. 2.4 volts, you can see. So basically that track from the middle, that's the track we are looking for. I lost it. Yeah, there, that one with 2.2 volts. So we are looking for that track. So from now on, it's very simple. We can short that track to ground and problem solved. Or we can do it like originally. I will say let's start doing it. And let's reach that track. That's the one. That's the track I'm looking for. 1 second, because here we have 3 layers. So the first one, it is ground. So this one is ground. This one is ground. Yeah. And this one is ground. Wait, I don't understand. How can be ground? This one is ground, this one is ground, the top one is ground. So which is my track? That one? The small dot there? So the battery is plugged. And this track has 0. This track has 0. Wait, so where is my track? Look, I have it here. I have it here. Here inside of the... But why is not here? Because we checked here. Huh. It's not here. That one? This one? Yeah, that's the one. That's, check on the screen, 2.4 volts. That's the track I need. Yeah, that's the one. This one. So on here we have 2.4 volts. Yeah, that's the track we need. Perfect. Now solder iron. We need some rosin. I'll use a proper calibrated wire, but this wire has a isolation over. So somehow we have to do a good job here, because we have to solder the charging port. And we are coming with hot air, and bad things can happen. Let's clean and seal the deal. I believe it's solid enough. I need like a proper small brush. I'll say it's good enough, right? Can we say that? Yeah, it is solder. Okay, so I'm gonna use some UV gel. UV or something better. UV. UV should be fine. UV. Perfect. Perfect. Now UV light. And hopefully it will be fine. Okay, this was a tricky fault. I mean, it took me some time. But I never met before issue with no charger ID pin. No, I'm getting confused again. Actually, the ASUS is not using the charger ID pin, but it's using this pin. When the charger is plugged in, then this pin is switched to ground and probably starting something. It's telling to the power management chip or the AC chip the charger is plugged. Which, if you ask me, is kind of stupid. I mean, if the laptop is seeing 19 volts on the input, that means, yeah, it means the charger is plugged, right? For some reason, they like to complicate a simple thing like this. Now, the reason why I'm not drilling more is because we are going to reach the ground here. And then we can, start having some issue. On the other end, I don't want to damage this ground pad because it's for the charging port stability. But we are fine, yeah? We are okay. So I'm going to solder the charging port back. Okay, let's try to solder the port. And the port is soldered in place. Perfect. Let's solder quickly the port. I mean, it's nearly perfect. Actually, it's not much what I can do here. It is soldered properly. Perfect. Now let's see what we are doing now. The pin penetrate the, and the pin is here. Perfect. No, I don't want to solder the wire. I want to solder this wire there. You'll probably get solder anyway. Perfect. Perfect. So we solder the wire. Now I want the wire around here. Like that. Let's test and then we can finish. Power supply. No, because we need that pin switch to ground, right? Yeah. Original charger. Let's go the original charger. Plug in the charger. And the battery voltage is going up. It's going up. That's crazy. It's working. But we can check on a different way. Let me unplug the power from the charger, but just leave the charger in. So the charger is disconnected. So I'll come with the power supply here and here. 2.5 amps. I can't believe. So actually it's working. 1 second. I don't have enough current. 2.4 amps. But the power supply is on the limit. 1 second. I don't have enough power. No. Let me plug the original charger. We plug back the charger. I don't have enough current on my power supply. And the battery 16.3 and still is going up. You remember it was like 14 volts and it's going up. And the board is on also. I can feel the heat here. What a job. What a job. That's crazy. Yeah, and the fans are spinning, you can see. Yeah, it is hot. Very simple, you can check the voltage on a current sensor, this one from the charging. And yeah, like 2.4 amps the charging current. Yeah, 24 millivolts. So let me tell you what happened. The laptop died in the moment someone replaced the charging port, like how the customer said. On that moment, the charger died. But remember, the customer said the laptop was not coming on every time and he has to wait for a while. Well, I believe that was an old issue and this MOSFET was shorted. This is not very important, but still, I believe that was the issue. The customer said he has an old issue with the laptop not coming on. He has to wait for a while. We done it. We done it. It's charging fine. Check there, 16.6, and it's still going up. Now, if you have this kind of fault, have in mind, because I didn't know that. Yeah, I didn't know actually the ASUS is not using the charger ID pin, but it has a pin which it will switch, it will be shorted to ground soon as you plug the charger. Crazy. Wow. Okay. You know what? You know what? Yeah, that will be long to put it all back together. I will use some hot glue just to be sure everything is like a sandwich, like proper fit there. I'm not gonna keep you anymore, but clearly this laptop, it is working and charging. Look, like 60.6. If I unplug the charger, unplugging the charger, check the voltage, 15.1. You can see, and the voltage obviously is going down because the board is on. You can see the fans are spinning. Plugging the charger back, and now the voltage is going up. Check that, 16.4. Yeah. What a job. Insane, but I'm happy I fixed it. And you know what? After I ordered the chip, I was thinking, what about the charger ID pin? But I started the job, and now during the video, I seen there is one more pin, and like, okay, well, for what? For what is one more pin? And yeah, that's the pin. I will keep in mind next time when I have ASUS to fix. Yeah, insane job, insane. I'm assuming, and I'm pretty sure about that. I'm assuming I can short that pin to ground, and it will work fine, even either with charger or without charger. Probably that pin is. You remember we seen some Acer and ASUS. They have to detect the charger is all the way plugged in, and I believe that's what that pin is doing. Yeah, it's detecting the charger is plugged all the way in. And yeah, like we did on other video, shorting that pin to ground, and it's working fine after that. Yeah, all back in place, and check here. Time until fully charged. That means the laptop, it is charging, and we have an estimate time till fully charged. All working fine. Anyway, I'll say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.